Today, we're going to try and answer a very simple sounding question, which turns out to be a bit of a stinger. How many bacteria are in this bottle of water from a freshwater lake? Now, to do that, we're going to need a whole host of lab techniques, so we're going to take you through them one by one to try and get to an answer at the end. Let's do it. So, if a liquid sample has just one bacterium in it, and we put that sample onto an agar plate and the bacterium is allowed to grow and reproduce, it would develop into a single visible bacterial colony. This gives us a method for working out how many bacteria are in a sample. If there are only a few bacteria in the sample, then a few bacterial colonies would develop and could be counted, showing how many bacteria were in the original. But if the sample has too many bacteria, the colonies all join together and you can't count them. So to get around this, we can dilute the sample again and again, and a sample of each dilution grown on agar plates. This is what we call a serial dilution, and eventually we'll have diluted the original sample enough that one of them should have a number of separate colonies that are countable. Then we can do some maths and scale this back up to work out how many we had in our original undiluted sample. Still with me? First things first though, we've got to take some safety precautions. We don't know what's growing in the lake, so this is both to protect our work from contamination and us and everyone else in the lab from infection. So that's job one. Okay, so we've given our colonies a few days to grow, and now we can choose a suitable segment of our plate to run our counting. Ideally, we want somewhere between 10 and 100 colonies on the segment. Now, I've used a full plate for each dilution here rather than putting all 6 on one plate, so this one from tube 3 has too many to count. This one from tube 4 looks good, and I've counted exactly 96 colonies. That was in our sample of 1 drop, which is about a 20th of a milliliter, so that's equivalent to just under 2,000 bacteria in 1 centimeter cubed. 3 1 in 10 dilutions were made from the original sample, which means we need to multiply our 2,000 by 10 to the power 3. That's just under 2 million bacteria per centimeter cubed in our original bottle. So that's how we answer our question. 2 million bacteria in every milliliter in this bottle. Now, there are a huge number of variables that are very difficult to control, so your answer may well be completely different to mine. And thinking about how to overcome these issues is the great challenge of experimental science. It's something for you to consider once you've got your result. Thank you for sticking with us. Do use this protocol in the lab when you need to, and we'll see you next time.